let's go ahead and look at a secondary port problem. I'm going to go ahead and look at problem number 1, which asks us to find all the times and all the heights of high and low water for Broadstairs on the 10th of July. I'm going to go ahead and go to the secondary ports page at the back of my tide tables. And in the problem, Broadstairs is labeled 102A. And looking down the left-hand side of the secondary ports page, when I find 102A, that's going to help me to find Broadstairs. The first thing I want to note for Broadstairs is that it is a secondary port, and the corresponding primary port is going to be Margate. Ultimately, I'm going to come back to this data, which is going to give me time and height adjustments for my secondary port. However, the first step in working a secondary port problem is to find the associated standard port, Margate, and find out the times and heights of all high and low waters for that standard port to which we will apply these adjustments. Here's the data for Margate, and we're looking for the 10th of July. Here's the 10th of July at Margate, and here's the 4 high water and low water times, as well as their corresponding heights. I'm going to go ahead and copy all of this data down once, because again, the more times I go in and out of this book, the more chances that I have to make a mistake. I'm going to go ahead and label this Margate so I don't confuse that data. And this is the standard port. I'll just go ahead and note that. For the 10th of July, I have a high water at 2:44 in the morning. Corresponding height is 4.3 meters. I have a low water, 08:38 in the morning. Corresponding height is 1.1 meter. 14:43 is our next high water at 4.4 meters. And then finally, 21:14 will be a low water at 0.9 meters. I can again apply my tidal curve to that data to remind me which of those are highs, which of those are lows. And this is the data that we're going to utilize when we find the times and heights for our secondary port, Broadstairs. Before I look at the secondary port data, you're also going to be asked to find the range of tide. Now, technically, I've got 3 different ranges, one here, and one here for this particular day. And in reality, it's possible that one of these will meet our definition of a spring tide, and the next one might meet our definition for halfway in between. However, for this problem set, that's usually not the case. So I'm just going to work out one of these ranges. So that's always high water minus low water. And I'm just going to pick the first 2 here. If you knew you were trying to find a tidal height in between these 2 times, I'd probably work with those ranges instead. But for this problem, I'm just going to go ahead and pick these first 2 values. And I'm going to make the assumption that no matter which of these values I choose, it's going to work out to a near enough number that it won't change my answer. So 4.3 minus 1.1, that should give me a value of 3.1 meters. So with that range, I'm going to briefly consult the Margate curve. This is the only thing I'm going to need the curve for in this particular problem. And what I want to do is compare the range that I've calculated to our spring and neap ranges. So the mean spring range for Margate is 4.3 meters, and the mean neap range for Margate is going to be 2.5 meters. Now, today's range does fall in between these 2, so I also want to consider the value halfway in between these 2 given values for springs and neaps. To do that, I'll add them together and divide them by 2. And when I do that, I should find 3.4 meters is my answer. Now, the instructions ask us to compare this number and this number. And the rule is if they're within 0.3 meters of one another, then for subsequent workings, we will assume that we are halfway in between springs and neaps, which could make us go in between the curves, or will have an impact on the secondary port data that we utilize. In this case, these two values are within 0.3 meters of one another. So we're going to use what I would call halfway between springs and neaps. From here, we're going to come back to our secondary ports page, and we're going to go ahead and extract some data. If you write neat, you can take all of the adjustments for both time and height for your secondary port. However, I'm just going to deal with the heights first, and we'll deal with the times later. The heights are ultimately a little bit simpler. I'm going to go ahead and copy this data over onto my work because, again, the more times I'm in and out of this book, the more chances I have to make a mistake. And what I want to copy down is what I'm going to call the height differences. I'm going to go ahead and abbreviate that. You'll see that up at the top of the page here for height differences. Below that, you're going to find height differences for mean high water springs, mean high water neaps, and onward. So we'll go ahead and copy that down. Mean high water springs, mean high water neaps, mean low water neaps, and mean low water springs. And then coming all the way down the page back until you are next to your secondary port, you're going to find right here the corresponding height adjustments, which in this case are minus 0.2 and minus 0.2 meters, and then minus 0.1 and minus 0.1 meters. Now, there's a coincidence here, which is that for our secondary port of Broadstairs, whether you're working with a spring tide or a neap tide, the height adjustment is the same. We had decided we were halfway in between springs and neaps, and so we would want to consider what's halfway in between these two values. Now, if those numbers were different, the value we would ultimately subtract from our tidal height would be halfway between these two values. Since they're the same, the value we subtract is going to be the same. But just to show you how I would do that math, plus a negative, or you can just subtract, divide by 2, that should be minus 0.2 meters. You could do the same thing here, but I think that you'll find that the low water adjustment is going to be minus 0.1 meters. So these are what I would call our height adjustments, and this one corresponds to high water and this one to low water. So carefully, I'm now going to apply these to the correct tidal heights above. And I like to notate it like this. High water 1 right here is 4.3 meters. To that value, I'm going to take the high water adjustment, 0.2 meters, and go ahead and subtract it off. Now, be careful. The next value you get up here is a low water, so I'm going to call that low water 1, 1.1 meter, and I'm going to subtract off the low water adjustment. You could do your high waters first and then switch over, but in this case, we'll work them in order. Just being careful to apply the correct data. And for our final low water, 0.9 meters, we'll again subtract the low water value, and that'll give us. Now, this is about half of our answer here. These are the adjusted tidal heights for our secondary port. I'm just going to hang on to that data for the moment because I still need to do time adjustments. But in my final answer, I'm going to come back to these values and you'll see them represented alongside the corresponding times. Okay, so the second half of this problem is going to involve doing time adjustments. I've switched to a fresh page to keep myself organized, but I've copied the data from Margate from the top of the previous page, Margate again being the standard port, so that I have the correct times to which I will apply the height adjustments. I'm going to go back to my secondary ports page, And I'm going to go ahead and write down the values for the time differences now. You'll find the time differences right here. You're going to have time differences both for high water and for low water. And there's quite a bit of data that we can write down that corresponds to those. Next to our standard port Margate, there's going to be 8 times to place. And I'm going to go ahead and make sure I separate those so that I know that I have high water adjustments and low water adjustments. With those values from Margate, I now also have adjustments for Broadstairs, -20 and -8, +7 and +10. And this is all the data that we need for our secondary port in order to find the time differences for that secondary port Broadstairs. And the way I look at this data is it tells me that if the high water were at 1 a.m. at Margate, it would be -20, 20 minutes earlier at Broadstairs. Or if the low water were at 7 a.m., it would be 10 minutes later, 7:10, at our secondary port Broadstairs. But the trouble you're going to run into is that 2:44 is not 1 a.m. or 7 a.m., yeah? It's actually in between. And therefore, your adjustment is also in between. And this next step is where it's pretty easy to get lost in the weeds. So we just want to do our best to stay organized and keep track of the data we're working with and what it is we're trying to find. And we're going to do a little bit of cross multiplication, but we're going to do that same process 4 times over, and hopefully by that 4th time, muscle memory will help you understand what it is we're doing. So the first time that I need to adjust is 2:44. So I'm going to go ahead and write that down here. This is a high water. So from my high water adjustments, I'm going to find the values it falls in between. It falls in between 0,100 and 0,700. And I like to draw myself an arrow showing the direction that time flows. And I'm going to put my 2:44 somewhere on that time interval. Doesn't have to look pretty or accurate. There is a means of doing this by a graph, but I'm not doing that here. Then I'm going to take the adjustments. Again, if it was 1 a.m., the adjustment would be -20 minutes. And if it were 7 a.m., it would be -8 minutes. So I'm going to go ahead and draw another arrow here. And I'm going to go ahead and mark it off. And this right here is the adjustment that I need to find. And what I'm going to do, again, is a little bit of cross multiplication. But what I'm looking to do is say, well, there is some time interval here between 1 and 2:44 that I can compare to this total time interval between 1 and 7 a.m. And then there is a comparable interval in between 20 and 8 that will tell me where this adjustment is. And I'm going to go ahead and name each of these intervals. And let's just give them easy names. Let's call this one A. Let's call this one B. Let's call this one C. And then this is what I'm looking for. Could call that, I suppose, D. And I'm going to use an equation. Looks something like this. A over B times C will give us D. And we're always going to work in minutes. Now, that's a little weird, but if you try to do this in hours and minutes, like we would normally tell time, your answers are not going to work out nicely. So for this first one, what I'm going to look at is how many minutes are there between 1 a.m. and 2:44? Well, there's 1 hour from 1 a.m. to 2 a.m., 60 minutes, and then an additional 44 minutes. So interval A, when read in minutes, is going to be 104 minutes. Then, interval B is going to be the number of minutes between 1 and 7 a.m. Now that's 6 hours, but you're going to use this number repeatedly, so you can just remember it. But 6 hours times 60 minutes is going to be 360 minutes. Then I'm looking at the number of minutes between 20 and 8. Now it's weird that there's like negative symbols here. However, you can kind of ignore those negative symbols for the moment and just think about how many spaces or how many minutes or how many digits are there between 20 and 8. And I think you'd find there are 12 minutes between 20 and 8. Now, I definitely recommend getting the calculator out for this one, so I'm going to have to do that as well. 104 divided by 360 times 12. I've got 3.46, and I'm going to round that to the nearest minute. Now, I can either round that to 3.5, or I can round it down to 3. And so in this case, I'm going to round that down to 3 minutes. And again, this is not the time adjustment that you're going to apply to the time of day. This is merely interval D, or where your adjustment sits between these two values. So I've rewritten those two values here, minus 20 and minus 8. And again, it's weird that that's a negative, but just try to ignore that negative number for a moment. And what D is telling you is if you are working from 20 towards 8, you want to count 1, 2, and 3 minutes over. Meaning the adjustment that you were looking for is going to be minus 17 minutes. So we're going to take that value and the time of day that we were working with, which is 02:44, and subtract that 17-minute adjustment. What you should find is that takes you to 02:27. This is your answer for the time of high water 1. We do have to do one more thing to that before I call that an answer, but we need to repeat this process a few more times for each of our high and low water times. So this was high water 1. I'm going to run through these a little bit more quickly. When I'm working time adjustments, I do like to work high water first. So I'm going to work high water 2 next. High water 2 is 14:43. And I'm going to use this same data for high water 2, except 14:43 is in between 1 p.m. and 7 p.m. So we'll go ahead and take 1300, draw our same arrow with our time on the scale towards 1900. Corresponding adjustments of minus 20 and minus 8, and the corresponding adjustment that we're looking for. We're going to do our cross multiplication again. A over B times C will tell us interval D. And so working those same values, we're going to have 60 minutes between 1300 and 1400 and an additional 43 minutes. So that's going to be 103 divided by the number of minutes between 1300 and 1900, 6 hours. So that's always going to be 360 minutes. Multiplied by the number of minutes between 20 and 8. That's going to be 12 minutes. And again, it's good to get out the calculator for that. It's probably going to be similar to our previous answer, but that won't always be the case. In this case, I've gotten 3 minutes again. And again, this is not my adjustment. This is telling me where in between 20 and 8 my adjustment is. And I'm working from 20 towards 8. So 19, 18, 17. Again, therefore, the adjustment is going to be equal to minus 17 minutes. We'll go back to our time of day, 02:44. That's the wrong time, isn't it? 14:43. Sorry. We're going to take our high water 2, which is 14:43, and we're going to subtract that adjustment. Not a bad idea. Get out the calculator. Make sure you don't make a math error. 43 minus 17, 26. So that's going to be 14:26 for the time of high water 2. Now, I'm running out of space again, so I'm going to go on to one last page, and I'll copy the relevant data again, which is going to be our tidal times and the low water adjustments. All right, so I think we're on to our final page of work here. We have done our height adjustments, and now we've done our high water time adjustments, which leaves the low water time adjustments remaining. So let's go ahead and work low water 1. I've gone ahead and copied the tidal data again. So low water 1 is 08:38 in the morning. And here's the corresponding time adjustments. We've got 7 and 1300 is when 8:38 falls between. And we've got adjustments for 10 and 7 that will apply to this value ultimately. Now, something that's going to look different to you and might bother you at first, but isn't going to be any different than our last problem, is that the way this data has been presented, 08:38 is going to look a little awkward at first. But 8:38 in the morning falls between 7 a.m. and 1 p.m. 1300. So I could, if I wanted to, go ahead and draw an arrow here. So I'm going to go ahead and copy 0700 right here, draw an arrow that way, and 1300 here, and then put the corresponding adjustments of 7 and 10 right below there. Now this is the same thing I had set up as before, except the arrows pointed the opposite direction. Now if that really bothers you, you can flip this over and put 7 here and 1300 here. Draw the arrow in the normal direction. However, if you do that, you also need to switch these two adjustments because 7 corresponds to 13 and 10 corresponds to 7. And I find that when people flip that arrow, at least half the time they also forget to flip these adjustments, which will result in the wrong answer. So I'd urge you just to leave this data as presented. But following the arrow, this time we'll call this interval A. The number of minutes in between 7 and 1300 is going to be interval B. The number of minutes between 10 and 7 is going to be interval C. And then we've got an adjustment that we need to apply that lies some distance in between those, interval D. And we're going to use A over B times C gives us D again, and we're going to do our work in minutes, just like we did before. So to complete the adjustment for low water 1, we're going to look at the number of minutes between 7 a.m. and 8 a.m. That's 60 plus an additional 38 minutes. So that's going to be 98 minutes. The number of minutes between 7 and 1300, it's going to be 6 hours. So 6 times 60 would be 360 minutes. Times C. This time C is the interval between 10 and 7 minutes. And there's 3 minutes in between 7 and 10. And so pull out the calculator. Second to last time. 98 divided by 360 times 3. I'm going to go ahead and round that 0.8 up to 1 minute. It's a lot of work for a 1 minute change, but that's what it is. And that's not our adjustment again. That's the number of minutes we need to work from 10 towards 7. And don't think about it like adding, subtracting. Just think about it like counting from 10 back to 7. And we're counting 1 space back. So therefore, the adjustment that we were seeking is going to be plus 9 minutes. We're going to add that to the time of day. So 08:38 plus should give us 08:47. and that is the time of low water 1. We need to do that one last time. We're going to do it for 21:14 in the evening. 21:14 is in between 1900, 7 p.m. and 1 a.m. So down here, we'll go ahead and write a space for low water 2. That's going to be in between 1 a.m. and 7 p.m. 1900. Time, though, goes from 7 p.m. to 1 a.m. Here's 21:14. The corresponding adjustments are plus 7, plus 10, and we're going to have interval A, interval B, interval C, and interval D as normal. The number of minutes between 1900 and 21:14, that's going to be 2 hours, 120 minutes, and an additional 14 minutes. So that's 134 minutes. Over 1900 to 1 a.m., that should be 6 hours. That's going to be 360 minutes times 3 minutes. Again, last time we'll get the calculator out. 134 divided by 360 times 3. We'll round that again to 1 minute. Again, that's not our adjustment. That's where our adjustment is, counting from 10 towards 7, 1 space. So therefore, our final adjustment is also plus 9 minutes. We're going to go ahead and add that to the time of day, which was 21:14 plus 9. Do that math out, we should get 21:23, and then that is the time of low water 2. That's my workings done. All I need to do now is go back through my work and collect the times of the low and high waters and also the heights back from that first page of work. I might save some space down here at the bottom where I'm going to go ahead and write my answer. So for my secondary port, which was Broadstairs, here's the times and heights that they had asked about for the 10th of July. And one other thing I need not to forget is, since I am working on 10 July, we're going to need to add 1 hour to convert these times to BST, or British Summertime. All right, so the problem had asked us to find the times in British Summertime and the heights of all high and low waters at Broadstairs for the 10th of July. So now that we've arrived at the end of the problem, here's our times and our heights, having added an hour to the calculated times to account for British Summertime. So we've got 327 at 4.1 meters, 947 at 1.0 meters, 1526 at 4.2 meters, and 2214 at 0.8 meters. I'm going to go ahead and note which ones are high and low waters, just for my reference going forward. And that's the end of this particular problem. In a subsequent problem, they could ask you then to also calculate exactly when the tidal height will be a given number, in which case we can take the standard port, Margate, and apply the secondary port data in order to use the tidal curve.